In this 3 steps to sketch, we'll graph the shifted cotangent graph, y equals negative cotangent of x plus 3 pi over 4. We know we need to use the shifted version of our method because we see in the parentheses with the x the plus 3 pi over 4. So that's our big clue, use the shifted method. Okay, so as a reminder, here's our template for our shifted cotangent graphing method. This will help us stay organized. Remember, step 1 is all about finding the essential information and getting organized. In step 2, we'll lightly plot the base pattern for a cotangent graph. And in step 3, we'll shift that pattern. That'll be our final graph. We'll sketch it in and then repeat. So as we get started, recall that the general form for a shifted cotangent graph is y equals a cotangent of bx minus c plus d. Notice that our equation has a plus sign here, and so we need to note that our general form equation is in that bx minus c form, so we need to interpret this plus sign as minus a negative 3 pi over 4, and that'll come in handy when we start talking about the shifts. All right, for now, let's start analyzing our base graph. We see that our value a is just that leading coefficient, or the term, the constant in front of cotangent. It's an understood -1. So we'll mark that. That's going to help us with our y coordinates of our curve setting points in the base pattern. And the negative is going to make it a reflected or a vertically flipped graph from the parent function cotangent x. So I like to put a little star there just to remind myself it's going to be a flipped version of the cotangent graph. Okay, b is the coefficient in front of x, an understood 1. That tells us we'll have one cycle of our graph happening between 0 and pi. That's a nice thing to double check at the end if you'd like. And we also use that to find our period. So for any cotangent graph, our formula for finding the period is pi over b. So in this case, that's pi over 1, or just pi. That's the length of one horizontal cycle. All right, now that we have that, we're ready to choose how to label our axes. So what scale should we use? For the horizontal axis, we want to be really intentional. Take your period and divide by 4. So we'll count tick marks by pi over 4. And this ensures that in step 2, each of our key features of our base pattern will align nicely with each horizontal tick mark. It's just making it as easy as possible. All right, then our vertical scale, usually 1 works well. Look at that value a. It's -1, so 1 should be really good. All right, let's take a moment now to label our grid before we move on to talking about shifts and asymptotes. Horizontally, we're counting by 1 pi over 4. So we have 1 pi over 4, 2 pi over 4 reduces to pi over 2, 3 pi over 4, 4 pi over 4 is pi. And this fourth horizontal tick mark here usually should match your period. Okay, so everything looks good there. We'll label the negative side of the horizontal axis here, all the same values, just negative. Easy enough. Okay, and then we'll label our vertical axis, counting by 1s. All right, so now we're all set up and we're ready to talk about our shifts. So first we'll talk about our phase shift or a horizontal shift, and we calculate that with c over b. And earlier we said that because our equation has x plus 3 pi over 4, we need to make sure to interpret that in the form of the general equation. So that's actually x minus -3 pi over 4. Our term c is -3 pi over 4. Okay, this just makes sure we shift in the correct direction. So c over b, b is just 1. So c over b must be -3 pi over 4. Okay, or that indicates we'll be moving to the left, 3 pi over 4. And notice that with our scale, that's going to be 3 horizontal tick marks to move the appropriate 3 pi over 4 to the left. All right, and then D indicates a vertical shift. We do not have a vertical shift here. You see there's nothing past the closing parentheses or parenthesis on the cotangent function, so no vertical shift here. And the last piece of analysis before we graph, let's find our asymptote generating equation. So it's very easy to find this. We're basically going to apply our horizontal transformation to our parent asymptotes of cotangent x, which happen at 0 plus pi k, where k is an integer. And we do that because vertical lines are only affected by horizontal transformations. So we find those horizontal transformations as the inputs of our cotangent function, and we can just write that as x plus 3 pi over 4 here. Set them equal to the parent asymptotes, 0 plus pi k. And then we just solve for x. So we subtract 3 pi over 4 from both sides. And notice that 3 pi over 4 is only going to be subtracted from 0 on the right side. Pi k is its own like term or own type of term, so it's not like with 3 pi over 4. All right, and we'll write our asymptotes equation simplified down in the asymptotes blank. We're going to have our asymptotes for our equation at x equals negative 3 pi over 4 plus pi k. So substitute in a few integers for k, and that'll give you some asymptotes. So when you let k equal 0, we know we should have an asymptote at negative 3 pi over 4. Let k equal 1, simplify there, we should have another asymptote at pi over 4. And you can do that for different values of k to get as many asymptotes as you want. This represents all of the asymptotes for your graph, so it's a really neat way to represent. I like to do this now just so I'm already expecting where my asymptote should fall for my final graph in step 3. But sometimes all you want to know for a particular equation or graph is where are the asymptotes, so this is a great way to do it. All right, we've done the bulk of the work. Now we're ready for step 2. Let's plot our base pattern for cotangent. And we see this little star. We know that it's going to be the reflected version from our parent graph y equals cotangent x. That's just something nice to be expecting. Remember to do this lightly, and our base pattern is going to be asymptote starting on the y-axis, curve shaping point, 0 or x-intercept, curve shaping point. And those will all align nicely with our horizontal tick marks as we move to the right. So again, do this lightly. This is not our final graph. Start with your asymptote on the y-axis. Our first curve shaping point happens at that first horizontal tick mark to the right, pi over 4, and its y-coordinate comes from our value of a, so negative 1. Okay, our 0 happens at the second horizontal tick mark to the right, so at pi over 2. And our final point, our second curve shaping point, happens at 3 pi over 4, and its y-coordinate is just the opposite value of a. So you can see here a reflected cotangent x graph is what we're working with. Of course, this is not our final graph. We're ready now for step 3, where we shift, then we'll sketch our final graph and repeat. So we'll take each of the pieces of our base pattern, and all we have here is a phase shift of left 3 pi over 4. That's 3 horizontal grid units. So move each piece of the base pattern left 3 pi over 4. So move that vertical line, that vertical asymptote, left 3 pi over 4, and look, it falls on what we talked about earlier. When k is 0 from our asymptotes equation, we should have an asymptote at negative 3 pi over 4. So everything is connecting and falling into place. So now move each of your points to the left 3 horizontal grid units, or to the left 3 pi over 4. Easy enough. And now we have one cycle that we can sketch in for our graph of negative cotangent x plus pi, 3 pi over 4. Now we can repeat this pattern for as many cycles as we want. First, we'll start with an asymptote here at pi over 4. Remember, that's what we said we should get when we have k equal to 1 in that asymptote generating equation. And then you simply repeat the pattern again. So you have another cycle here of our cotangent graph. And of course, you can work in the other direction too. We don't really have too much room there, but you can see how you would extend. And you have about 2.5 cycles of the graph here. That's all there is to it. Hopefully this helps you understand the 3 steps to sketch method for graphing shifted cotangent graphs. Be sure to check the links in the video description. There will be links to playlists with a bunch more examples for graphing cotangent, as well as graphing all of the other trig functions. Thanks for watching.